Good day everyone! In this video, we will be discussing the movement of plate tectonics, and with our experiment, we will be answering the question, if there will be no movement in the plate tectonics, what would likely happen to the Earth's surface? So stay tuned to learn more!
For today, we will be tackling the concept of the movement of plate tectonics through our experiment, as well as to analyze its inner workings in order to understand its importance to the Earth, while also explaining what would happen if there is an absence of its movements. We will be conducting two demonstrations in order to fully explain the mechanism of plate tectonic movements, which are the chocolate powder experiment and the oobleck experiment. And now, let's proceed with our demonstration.
For conducting the hot cocoa experiment, we will be needing the following materials: a cooking pan, 1/3 a cup of milk, 2 cups of cocoa powder, stove, and a timer. Our first experiment, which is the hot cocoa experiment, will be conducted as follows. First, we gather all the materials needed, and then second, prepare the heat source that will be used to heat up the content. Put up the milk into the pan as our liquid matter, and on top of it, the chocolate powder that will act as the crust of the Earth. Start the stove on medium-high heat, but do not stir the mixture. Set up a timer to keep track of the time as the milk and chocolate mixture began to heat up. And lastly, let the pan continuously heat up until the cracks start to form.
We will notice as the chocolate mixture heats up, cracks start to form. We can reflect this phenomenon on how the Earth's plate tectonics move and crack because of the heat or so-called convection currents situated below the crust. The liquid matter underneath the crust is moving, hence making the plates move.
When there is still no presence of heat in the mixture, the crust or the chocolate powder is smooth with no cracks visible. However, compared to when heat is applied, this causes the chocolate powder to crack and move.
The presence of the movement of plate tectonics is especially important, for it helps regulate the level of carbon dioxide present in the deep parts of the Earth's surface, and maintain a long-term stability of Earth's thermostat. Though when the plates stop moving, the planet would have to find a new and efficient means to blow off this heat.
Because a planet with too much carbon dioxide can end up like Venus. There would be a heat buildup that would make it too hot to be inhabited by humans, primarily by the accumulated amount of carbon dioxide. The movement of these plate tectonics is also important, for it is often associated with earthquakes and volcanoes that is critical to the development of life on Earth.
And then experiment number 2, the oobleck. For conducting our oobleck experiment, we will be needing the following materials: cornstarch, water, food coloring, and a mixing bowl. For our second experiment, which will be making use of an oobleck mixture, will be conducted as follows. Prepare all needed materials. In a mixing bowl, combine 1 cup of cornstarch and 2 cups of water until well incorporated. And then, add the desired amount of food coloring to the oobleck mixture. Observe its behavior and by kneading the mixture.
So first we get the 1/3 cup of cornstarch, and another is 1 cup of water. So while he's pouring the cornstarch, I'm going to get the red food coloring, pour it in the water. So there you go. Hey, that's good. That's good enough. Then pour the 1/3 cup of cornstarch in the bowl. Then we put the 1 cup of water mixed with food coloring into the bowl. Now we try to mix it. Mix?
Mix.
Mix.
Mix it. You mix it.
Mix?
Yes, you mix
Yes,
it.
I mix.
You mix it.
This one very hard.
So we're gonna put more flour,
Cornstarch.
cornstarch. We gotta put it right in the 1/3 cup. Serve that. Okay,
Please pour.
we're gonna pour it.
Will you look at that?
It's magic. So we're gonna add more.
So look. The water with the food coloring is mixed with the cornstarch. So observe when the cornstarch is being mixed with the water with a constant
Yes.
with the constant movement, it tend to harden, but and also with the constant movement, a solid material is being formed. But when it's not being moved, it's like it's being melted. So yeah. So cool, right?
So we add more. Go.
So that's it.
Thank
Now
you.
we'll go on to the explanation.
As seen in the behavior of the oblique mixture, it reflects the importance of the plate tectonic's constant motion.
It is quite evident from the two presented experiments that plate tectonic movements are relevant in maintaining the Earth's surface. However, when plate tectonics stop moving, it would lead to a number of changes in the Earth's form.
One of the changes that would occur is that the Earth will just keep getting flatter. The movement of Earth's tectonic plates shape the planet's surface, and their boundaries play an important role in geologic happenings. Additionally, the movements of these plates atop the thick, fluid mantle from totally seeping through.
Another point is when the Earth's tectonic plates grind past one another. Enormous amounts of energy can be released in the form of earthquakes or the release of volcanic material. An effect of the absence of plate tectonic movements is the non-existence of both mountains and the volcanoes, which can help shape the Earth's surface.
Another effect of the loss of plate tectonic movements is that there will no longer be a carbon cycle. Carbon cycle refers to carbon dioxide being released into the atmosphere when volcanoes erupt, earthquakes are formed, and through a variety of other mechanisms. This process of moving plates stabilized our climate, making Earth habitable.
The movement of the tectonic plates shapes our continents and the land around us. At the same time, the movement of tectonic plates alternately exposes and conceals mineral deposits that we use every day.
Plate tectonics revolutionized the way geologists view Earth. Plate tectonics explain nearly all of Earth's major surface features and activities. This includes faults and earthquakes, volcanoes and volcanism, mountains, and even the origin of the continents and oceans.